Hello guys, as you can see here we have a project of an Arduino with a TFT 1.8 TFT screen. We have a sensor, a BME 280, a Hall sensor, and of course the ESP32S, that is the heart of the design. Okay, this thing, the ESP communicates with thingSpeak and OpenWeather data, that it retrieves information about the weather. Here, as you can see, we have the wind speed, direction, and weather. That is a feedback from the OpenWeather.org. And with this, we control some things as a LED or something else. We can control a valve that we can use in an irrigation system in order to stop some actions or do other things. This project I have made is additional to another, that is, it is an irrigation project with 6 relays, and I wanted to have some statisticals about the flow rate of the water to see how the system, how well is doing its job, because in our area we have some problems with the pressure of the water. So I have managed to water the plants late at night, about 3 o'clock. The other system is a Arduino Nano, that has a real clock on it, and interact with 6 relays, as I said before, that are the lines we do the water of the area. Here you can see the screen is changing, and next to the screen you can see the BME 280. And here's a bunch of cables that is connected to the ESP. As you can see, I have a case for the screen that I have found in the internet. All these kind of additional things, I will have the links below, so in the description, so for you to manage to find in the web. Also, I have to say that I'm a newbie in programming. This kind of code that I have made is about 600 lines. It's a mix of a little project that the most I have to do is to mix it and take it to work. Here, as you can see in this screen, I have max flow rate up to the left. Some other, the right corner, if the screen managed to change, to switch, in the right corner I have the total liters that have watered my garden, and I retrieve this value. I retrieve it from thingSpeak in order, if I have some electricity problem, power supply cut, I retrieve it from the internet in order not to lose the data. As you can see here, the 180 value is liters, total liters, and it is a kind of a memory, because I thought about this a lot. If I do an SD card that you may have seen in some TFT screens, is embedded with SD card, you may store the data there, but there are a lot of problems, especially how many times you will store the data. It may be reach the limit of the card, and so for some reason it will stop retrieve the correct data. So I managed this to do it with thingSpeak, which is much easier. Then I have another things like this clock that is a Wi-Fi clock, okay, and as in here is what the whole sensor did. We have water time total. If the whole sensor start to work, the system starts irritating. Okay, water, the garden, it will compute some values such as the flow rate, and from the flow rate data we can retrieve all the other data like total liters and many of them, which I send then these kind of values to the thingSpeak in order to have some statistical of my system, my retaining system. Here you can see the another things from the BME sensor, which I have to mention that I bought it from the AliExpress for about €1, and the TFT screen for about €2.5. And it works pretty well. The temperature, humidity, and pressure are very precise, and I can I recommend strongly to make such ways. They both use Adafruit libraries, okay, but I have a problem with the Adafruit library for TFT, which I had a little research in the web, and I find that something had to be added in the library in order to have the screen print correctly all the things I wanted. Okay, I will now energize the whole sensor, the flow meter sensor of the water, in order to see what happens to the screen. Okay, here you can see the data from the BME. Let me, okay. Okay, now I simulate that the whole sensor is working. That means the rotating system is working, and I have made some functions on the screen in order to show me that in real time. Okay, as you can see here, the whole sensor worked. That means that I have some data from it. Okay, if the screen switch, you will see that data. This is real-time data, and in the other screen that it will change in a moment, it will show the max flow rate. Okay, the liters that watered that time, and finally at the end it will show the total minutes, 0.3 minutes of watering, and total 0 limits because it's under 1 liter. Okay. I have to say about the code for the whole sensor. I have found it in the web that it is tested by other guys and works pretty well. And it has a corrector factor that okay, um, um, correct any differences that you have from the for the data that you retrieve from the sensor in order to have the correct values. Okay, in the next screen, I have to say the last thing about the weather that retrieved from the OpenWeather.org. Okay, there you can see the wind data as speed and direction, and weather is clear. Okay, this clear, it can be rainy, clouds, or hail, haze, and snow and so on. Okay, I have made some LEDs. You can see here that is the LED is on if the weather is clear. I have two another LEDs if the weather is cloudy, if the weather is rainy. And why is that? Because if something is something about the weather, if the weather is not clear, so I have managed to have a valve to my retaining system in order to stop um, the watering. I made this because I didn't want to have all this code. I said before it is 600 lines approximately, all this code in the Nano, because the hardware today is cheap. I don't have to think about expenses. What to have one Nano with all the code that it will be over 1,000 lines. What to have two different systems that incorporates each other. So I have thought it in that way in order not to affect the other system that is active now, and I left it as it is with another Wi-Fi now with a embedded Wi-Fi ESP. So in order to have mostly statistical data, okay, statistical data. I have to say that I have a channel that is active in thingSpeak, is open now, and from my position, I can give actual weather conditions from the BME sensor. Okay, that's all I have to say. I waited from you your responses, your thoughts, your suggestions. Okay, as I said in the beginning, I'm not a programmer. Okay, I do it this only for hobby, and I have the system now working a lot of time, so I believe that it meets all the expectations, not only from me, but from you guys that you love Arduino programming. Okay, that's all from me. Thank you very much. Bye.